All right, so we are doing 10-4 for Algebra 2 of inverse of trig functions. So the idea of an inverse is just an opposite operation, all right? So our objectives today are to evaluate inverse trig functions, so plug them into our calculator, and then also use these trig equations and inverse to solve problems. So as I just mentioned, remember that inverse just means opposite operation. Okay, and so when we have our function like sine, cosine, or tangent, in order to get your inverse, you're just going to put this little tiny 1 right here. And if that looks familiar, it's because on your calculator it has it as well up here as the operation from the second mode. Okay. And so the idea is if you take sine of whatever degree measure you have, you're going to equal a number. But let's say that you take sine inverse of that result, you'll get back to the original degree. So one main idea is if you take the sine inverse of the sine of whatever value it happens to be, you're going to get that value back out because the sine inverse and the sine, just like the cosine and tangent, cancel each other out. All right. And so we're going to go ahead and try some of these. The first thing that we need to note is that you need to be in degree mode. Okay, so if we're going to solve these ones here, you need to be in degree mode. If you're in what they call radian mode, you end up getting something that is an answer but not easy to reference. So going to your mode here, notice that radian is not highlighted, and so that means that I am in degree mode, which is highlighted. And so if I take, for instance, the sine inverse of the square root of 2 over 2, I'm going to get a degree versus a radian. So in order to get sine inverse, I'm going to do the sine key, but second first. So second sine inverse. And then I'm going to do that of the square root of 2 divided by 2. So taking a look at how I type this, depending on what calculator you have, you do have to kind of close those parentheses and put that square root of 2 over the 2. So sine inverse of square root of 2 over 2 gives us a degree of 45. Again, if you were in the radian mode, you would have gotten 0.7853, which is not a degree. It is part of what we will learn if you advance to pre-calculus, so with the unit circle. But right now we are going to be in degree mode, and so we understand that that rotated 45 degrees. All right. Over here for cosine inverse of a half, again, to type that in, second and then cosine, 1 divided by 2, or you could put in a half as in 0.5, and we're going to get 60 degrees. So really these first two examples were just, are you in the right mode, and type it in. Moving on to the next examples, they want you to actually solve these. So what they're saying here is that cosine of some theta degree measure is going to equal 0.6. So how do you undo cosine? And so that's where we're going to take the cosine inverse of both sides. So if I take the cosine inverse of this left side, the way that it's written is cosine inverse of what originally was there, cosine of theta. And then that's going to equal the cosine inverse, because we can't take it of just one side. We have to be equal, of 0.6. So again, in blue here, I have the original problem, but in green, I have the operation that I am doing. So remember that cosine inverse of cosine, just like sine inverse of sine, cancels, and you're left with just theta. Then you're going to have that equal the operation of cosine inverse of 0.6. So if I do cosine inverse, second cosine, of 0.6 or 0.6, we end up with 53.13 degrees. And so that is our solution. So just as if this was being squared, we would have taken square root to solve. We're doing the cosine of both sides, so to undo cosine, you do cosine inverse. Same thing is going to happen over here, only now we're going to be doing from tangent, the tangent inverse. So we'll have tangent inverse of tangent of theta, and that's going to equal tangent inverse of -2. So taking the tangent of the inverse of the left side and tangent inverse of the right side. Just as it happened before, inverse and regular are going to cancel, and so we're left with just theta. And so theta is going to equal whatever the result of tangent inverse of -2 is. So tangent inverse of -2 is possible, and it's okay to have a negative degree measure. It just means that it would have rotated a different direction. So in this case, our degree answer is -63.43 degrees. All right, our last example here is an application. Looks like a group of hikers plans to walk from a campground to a lake. The lake is 2 miles east and a half a mile north of the campground. And so to the nearest degree, in what direction should the hikers head to get there directly? So taking a look at an image of what's happening, over here is the campground, and over here is the lake, and we're going to try to tell them what direction to head, okay? In order to get there, they could potentially walk to the right, which they're saying is east, 2 miles. And then they could walk north 0.5 miles. But of course, in order to save themselves some hiking, we're going to go ahead and just do this hypotenuse, okay? In order to get to that hypotenuse, we need to go some certain degree measure. And so again, we don't want this hypotenuse length. That's not what they're asking. They're asking what degree is this angle, so they should head that direction. So in that case, we're going to find this angle measure. And in order to find that angle measure, there's a few things happening. This is technically where we're standing. And this side over here is the opposite. And this side over here is the adjacent. This hypotenuse is here, but of course not helpful in the solving of this problem, so we won't reference it. But if we think of SOHCAHTOA, which one uses opposite and adjacent, and that would be tangent. So we're going to set up our problem as tangent of this theta that we don't know is equal to the opposite over the adjacent. But that means that our tangent of theta is equal to the opposite side length, which is 0.5 miles, over the adjacent side length, which is 2. And so in order to solve this, notice that we have tangent that is on the side with the degree measure that we want. So we're going to undo tangent by doing tangent inverse of both sides. And so we're going to do tangent inverse of tangent of theta. And we're going to do tangent inverse of our fraction of 0.5 over 2. And so again, tangent inverse and tangent cancel. And so we're left with theta by itself. And that's going to equal the tangent inverse of 0.5 over 2. And so the tangent inverse of 0.5 over 2 gives us a result of 14.03 or 04 degrees. And so this could potentially be our answer, but of course, if we're talking about hiking, it's not necessarily the easiest thing to just say go 14 degrees, because where is it from? So we usually use reference angles. And so in this case, you can say go east 14.4 degrees west. So east, 14.04 degrees, north. That's what we're looking for there. Another way to say it would have been north, and then what's minus 75.96 degrees east. So you could have also done this other direction if we think of this as north. This here would have been that east direction as well. All right. So again, all of these are the answers, but technically it comes from the number 14.04. All right, so again, the idea here is that in order to solve one of your problems, if you're trying to find this x or the theta or the degree measure, you need to undo the sine, cosine, or tangent with its inverse.